Thank you to a bunch of people who helped me think about this. Let's start with a cartoon. You've got a wolf and a sheep, and the wolf says to the sheep, "Could I eat you for dinner?" And the sheep says, no. So the wolf calls one of his buddies over and said, "Well, hey, could we eat you for dinner?" And the sheep says, still no. And then the wolf says, "How about if we take a vote?" Well, this introduces the tyranny of the majority problem, also known as why token voting sucks. To get through this, we need to accept three basic premises. Shareholder or token voting stifles the minority, whales are the overwhelming majority, and whales are a factor that drive voter apathy. If the whales are stifling the minority and exacerbating apathy, what the heck are we supposed to do? Back in September, I wrote an article called "What is Quadratic Voting Anyways?" I did it mostly to get my thoughts down on paper so I could understand it. This is a follow-up to that, and if you want more details on quadratic voting, just Google it. There's a ton of great articles out there. After I wrote that article, I still had three questions about quadratic voting. I wondered, is there an application for binary decisions, meaning for or against decisions? Does quadratic voting really empower minnows over whales, and do more voters equal better decisions? Back to the tyranny of the majority, let's talk about minnows and whales. As an exercise, let's vote. So up for proposal is EP 16.3 executable in Q3 and Q4. The proposal is whales will eat the minnows. So let's set this up. You've got two constituents. You've got the whale and you've got the minnow. Let's pretend you're the minnow. The whale has 2 million tokens, ergo 2 million votes. You're a minnow. You only have 1,000 tokens, which means you get 1,000 votes. So how does a minnow keep from getting eaten? Option A is you go find 2,000 other minnows to vote with you, or option B, go find $4 million so you can buy enough votes to counteract the whale. Let's apply quadratic voting. Same situation. The whale has 2 million tokens in hand, the minnow has 1,000 tokens. We take the square root of each one of those, and that equals how many votes you have. So the whale has 1,114 votes, and the minnow has 31 votes. To make this obvious, let's compare the two. In traditional voting, the minnows need to find 2,000 other minnows like themselves to keep from getting eaten. However, in quadratic voting, they only need to find 44 others like themselves. So let's go back to the three questions I had about quadratic voting. Is there an application for binary decisions? Absolutely. Does this empower minnows over whales? For sure. Do more voters equal better decisions? That's really kind of out of scope. Maybe we'll get to that next time. Thanks a lot. Hope you enjoyed it.